So my discrepant event is called a cool winter sun. The main purpose of this experiment is to demonstrate the difference between direct and indirect sunlight. The materials needed for this experiment are a plastic ball, a flashlight, a piece of paper, and two markers. In this experiment, I will use the flashlight to simulate the sunbeams. Say that the flashlight is a particular sunbeam. If the light is shining directly, all its energy is concentrated in a certain area. But if I move the flashlight to have an angle, we will notice how the light will hit the paper indirectly, and the area being illuminated will become larger. This means that the same amount of energy is spread out over a larger area. So in a particular point of the paper, it feels colder in the indirect sunbeam than in the direct sunbeam. And the more indirect the sunbeam, the larger the area. It's important to point out that the amount of energy in the sunbeam is always the same. It is not changing. However, if it is spread out over a larger area, we feel it. Now let's see what this means for our planet. I will use this plastic ball angle about 23 degrees to find out. It's July, so the northern hemisphere is angled directly towards the sun. If we shine the flashlight directly on the northern hemisphere, we see it illuminates a certain area. This is an example of how the sunlight strikes the northern hemisphere during the summer months. But when we move the flashlight to shine indirectly on the southern hemisphere, we can observe how the same amount of light illuminates a larger area, just like I talked about before. This is an example of how the sunlight strikes the southern hemisphere at the same time that we in the United States are experiencing summer.